Okay, we're going to have a look at this thing here called E of x, which is the mean or the expected value of a discrete random variable. Okay, E of x is the expected value or the mean of a discrete random variable. So if you see this, E of x, they're actually asking you to calculate the mean. Sometimes they'll ask you for the expectation. Okay, now it's really important that this next bit that I'm going to do, you don't write it in your pack, you just watch. Okay, so just watch this next bit. Okay, let's just imagine that I had some data in a frequency table. I don't know, x could be maths marks, and the frequency is how many people got each mark, 1, 2, 3, 4. So the first thing we're going to do is we're going to have a think about what we know about finding the mean from a frequency table. I hope you guys can remember. It's the x factor over f. Now, I'm going to write it in a slightly different way. So we'd do x times f, so 1 times 10, 1 times 10, and we'd sum them all together, so 2 times 20. You guys would write them out in columns, wouldn't you? 2 times 20, plus 3 times 15, 3 times 15, plus 4 times 5, so 4 times 5. And then we'd add all of that up. That would be our sum of xf, and then we'd divide it by the total frequency, and the total frequency would be adding that up, which would be 60. That is a frequency table, so I'm going to move him over. And what I'm going to do now is I'm going to think about what would happen if I didn't have a frequency table, I had a probability distribution, because that's what I have when I'm looking at a DRV. So the probability that big X is one of my little small x's. So what's the probability of getting a 1? Well, it would be 10, wouldn't it, out of 60. And the probability of a 2 would be 20 out of 60, and it would be 15 out of 60, and it would be 5 out of 60. So how am I going to find the mean? Right, if I look up towards the frequency table, can you see that the first value is 1, and I times it by 10, and then I divide it by 60, which is the same as doing 1 times it by 10 and divide it by 60. It's the same as timesing these two together. So we look at another one. If I wanted to do the 2, I times it by 20 and then I divide it by 60, which is the same as timesing those together. So in actual fact, all I need to do, if I have a probability distribution table, is to find the mean, which is known as E of x. I just need to take the x's and times them by their probabilities. And in fact, that's in the formula book for you. They don't have the times there, they miss him out. So it's just written like that. Okay, so if we're going to find the mean, or E of x, of a discrete random variable, or the expectation, we are going to write the formula out first. It's the sum of x times its probabilities. And I love this because you only need one piece of equipment. It's your finger. You're going to go plus, 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 plus. That's it. Okay? So we're going to go, now you're going to get fed up with this, and I'm sorry about it. There's nothing I can do. 1 times 10 over 60 plus 2 times 20 over 60 plus 3 times 15 over 60 plus 4 times 5 over 60, and you have to write that line out, gang. So 1 times 10 over 60 is 10 over 60, and you have to have this line. 2 times 20 over 60 is 40 over 60, plus 3 15s are 45 over 60, 4 fives are 20 over 60. And if we add all that up, we're getting 40, 85, 95. I think it's coming to 115 out of 60, which if we, well, I would probably leave it like that, but you could pop it as a decimal, 1.916 recurring, which I think is coming out as 1.92 to 3 sig figs. So the expected value, if these were exam scores, the expected value you would be likely to get would be 1.92. Okay, everyone, you have a go at this one. See if you can find the mean. All right, pause the video and I'll pop the answers back up. Okay, here they are. All right, easy. Yep.